Hello and good day everyone! Today we are going to vlog some of the topics of chemistry.
But before that,
I'm Lovely. I'm Shenby.
I'm Jermaine.
So, watch and listen to us.
Do you know about kinetic molecular theory? Kinetic molecular theory states that gas particles are in constant motion and exhibit perfectly elastic collisions. This is one of the examples of kinetic molecular theory.
Second topic is what we call the properties of liquids due to IMF, or what we call the intermolecular forces. So the properties are surface tension, viscosity, vapor pressure, boiling point, capillary action, cohesion, and adhesion. And we are going to take the capillary action and discuss how is it important to us. So what is capillary action, by the way?
Capillary action is the tendency of a liquid to rise in narrow tubes or be drawn into small openings, such as those between grains of a rock.
Capillarity action is also known as capillarity. Capillarity is a result of intermolecular forces between the liquids and solid materials. So, here's the example of the capillary action called the walking water.
This walking water is related to capillary action because, as you can see, that the colored water is creeping up our paper towel that we have.
But how is this possible?
The water molecules are attracted to the molecules in the paper towel, so they cling to one another and cling to the molecules in the paper towel and then spread up the paper towel.
Did you know that capillary action, especially for moving water, is important to us? This is why.
The movement of water in and out of your cellular structure deposits vitamins, nutrients, and vital blood plasma. Without this flow, our body's cells would not rehydrate and vital communication between brain and body would slow.
So that's how capillary action works. Another topic is all about the laws of thermodynamics. First thing first, what is the law of thermodynamics? The law of thermodynamics dictates how energy behavior, for example, Y and how heat, which is form of energy transfer between different objects. There are four fundamental laws of thermodynamics which express empirical facts and define physical quantities such as temperature and heat. Let's see how the laws of thermodynamics can be seen.
Sometimes you wonder how ice cream is made. One area of chemistry that helps explain the making of ice cream is thermodynamics. The first law states that the heat supplied by the environment serves as the blender to a system which is the ingredients to make ice cream is equal to the change of internal energy inside the liquid to make the ice cream.
Another topic is the colligative properties. But what is colligative properties anyway? Colligative properties are physical properties of a solution that depends on the solute or the amount of solute but not in the nature of solute. The four colligative properties are vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So we are going to take the freezing point depression and know about it or discuss about it and see how is it important to us.
What we're going to do is to get some water and salt, same as true with two glasses. The first one is a purely water and the second one has a green on top of it, has a salt and water. And we are going to place it in the refrigerator for a couple of hours at the same temperature and at the same time.
And this time, we're going to see how freezing point depression works. And let's just gonna put it here for a few minutes and observe how and what's gonna happen to them.
As we can see, the pure ice is faster to turn into liquid phase than the ice that has a sodium chloride.
How is that possible?
Any solute added to the solvent, the freezing point of a solution will be lower than the freezing point of the pure solvent. Freezing point depression is important to humans, especially vital to aquatic life. Since salt water will freeze at lower temperature, organisms can survive in these bodies of water.
So that's how freezing point depression works.
Crystalline and amorphous solid. Do you want to know crystalline solid? Crystalline solids are solids have a definite internal atomic structure that follows a regular repeating pattern. Amorphous solid is non-crystalline solid in which the atoms and molecules are not organized in a definite lattice pattern. Difference between crystalline and amorphous solid. Crystals have an orderly arrangement of their constituent particles. In comparison, amorphous solids have no such arrangement. Their particles are randomly organized.
Lastly, the concentration of solution. The concentration of solution is a measure of the amount of solute that has been dissolved in a given amount of solvent or solution. A concentrated solution is the one that has a relatively large amount of dissolved solvent. When there is a less amount of solute dissolved in a given amount of solvent, then the solution is unsaturated. But when there is a maximum amount of solute dissolved in a given amount of solvent, then the solution is saturated. How do we know the accurate amount of a solute in a solvent? Let's go find out together. When you are preparing a cup of coffee and you put too much coffee powder and too much sugar, then of course the color of the coffee will be too dark, the smell will be too strong, and the taste will be too sweet, since there are many sugar in it. The intensity of color, strength of the smell, degree of sweetness all depends on the concentration of solutions.
I'm Lovely.
I'm Shanvi. I'm Jerwayne.
Thank you!